Hello everyone, welcome to my channel Learn and Master Math. Today we will be discussing continuity using limits and graphs piecewise functions. What does continuity mean? A function is continuous at a point if its graph has no breaks, holes, or jumps at that point. Mathematically, a function f of x is continuous at x equal to a if all the three conditions are satisfied. F of a exists, the limit as x goes to a of f of x exists, the limit equals the function value. It means the limit should match the f of a in steps 1 and 2. If any of these fails, the function is not continuous at a. Points of discontinuity: use the graph to the right to identify values of x on the interval 0, 7 at which f has a discontinuity. As you see here in the figure, we have a discontinuity at 1, we have a discontinuity at 2. When you see an open circle, it's a hole. And there's a discontinuity at 3 since there's a break in the graph. We also have a discontinuity at 5, at x equal to 5. Let's talk about each one step by step. At x equal to 1, the point is removable. The reason of this discontinuity is that f of 1 does not exist. It's undefined. There's no point at all, as you see. At x equal to 2, there is a point, but it's not in the right place. So here there is a point, f of 2 is equal to 3. The limit as x goes to 2 is equal to 1, and the answers doesn't match. So the limit when x goes to 2 doesn't match the f of 2. And finally, at 3, we have also a jump. There is a point, f of 3 equals to 1, but the limit at the left and the limit at the right does not match, since the limit at the left is 2 and the limit to the right is 1. So the limit in when x equal to 3, it does not exist. We call it a jump. When x goes to 5, there's a vertical asymptote here, so we call it infinite limit. And here there's no point and no limit. It's infinity. Let's see how we find continuity from a function. By using the checklist, we actually follow the domain of each function. So since polynomials have the domain all real numbers, the polynomials are actually continuous for all x, exponentials as well. Logarithms also, you follow the domain. In this example here, we have f of x equal x squared minus 4 over x minus 2. Well, this is a rational function, and the denominator here is x minus 2. When x minus 2 is equal to 0, this will result with the value x equal to 2, which means actually we have to study the limit and the continuity checklist for f of 2. Well, f of 2, does it exist? How do we know? If we substitute x by 2 in this function, we will get 2 squared minus 4 over 2 minus 2. This is equal to 0 over 0, which means f of 2 is undefined. And here you can stop and see that the test fails. You don't have to continue, but I want to show you in this exercise how to differentiate between finding f of 2 and the limit when x goes to 2. So basically, when we are finding f of 2, we do not simplify. So it's a direct substitution, and then you see the result. But if I'm finding the limit, I should factorize and simplify first. So if you factor x squared minus 4 here, you will get x plus 2 into x minus 2. In this case, x minus 2 would cancel. So it is a removable discontinuity. The resulting function after you simplify is x plus 2. Well, if you substitute now x by 2, since you're getting the limit when x goes to 2, this will be 2 plus 2 equals to 4. But in the end, this function is not continuous at 2. And the type of discontinuity here is a removable discontinuity. Now let's see and study continuity of piecewise functions, like here in the function at the right here, x squared minus 4 when x is less than 2, 3x minus 2 when x is greater or equal to 2. First step, you have to compute the left-hand limit. It means when x is less than 2, you go and substitute x here in the first piece, x with 2. So finding the limit to the left of 2, this actually, the choice will be here x squared minus 4. So 2 squared minus 4 is equal to 0. Then you go and find the right-hand limit. So the right-hand limit is at 2 plus, which means x is greater than 2. Choosing the next or the second piece here, 3x minus 2, substituting x with 2, this will be 3 times 2, which is 6, minus 2, this is equal to 4. If you notice the left and right limits, they don't match here. So the limit does not exist. And if you want to check f of 2, you choose the one with equal sign. So the second piece here matches. If you want to find the first checklist, f of 2, you have to substitute 3x minus 2 by 2, which matches actually the right limit here. In general, the limit does not exist, so f of 2 actually it's equal to 4. We have a right continuity, but in general there is no continuity at x equal to 2 here, since the limit does not exist, and this is a case of a jump. And now it's your turn. You can check this example and leave your answers in the comment. Please answer if this f of x is continuous at x equal to 1, if it's yes or no, and tell me the reason. Bye, see you in the next video.